Our mind-blowing lead is way out of this world, 390 light-years away. Truth be told, for setting 1 light-year is indistinguishable from 6 trillion miles. In humankind's tireless journey for loosening up the secrets of the universe, we've set out on a mission that goes beyond time itself, searching for answers to age-old requests woven into the fabric of existence. The James Webb Space Telescope, with its unblinking eye, has recently identified a brief glimpse at a structure beginning before the formation of stars. This grand thing emitted an impression of being more antiquated than the actual universe, raising more questions than it answers. How could a plan exist that begins before our universe? Or is the hypothesis of how things came to be flawed? Join us as we embark on an odyssey directed by the discoveries of the James Webb Telescope. The secrets of a 13.8 billion-year-old evolution await, and the journey to unravel these vast mysteries has only just begun. In a distant corner of the universe, around 200 light-years away, an old star called HD 114283 lies near the Libra constellation. This eminent pilgrim moves vigorously through space, offering interesting brief glimpses into its violent past. Precisely quite a while back, during when our Milky Way was still in its earliest stages, it ingested a dwarf system that once called it home. Yet what genuinely piques our cosmic interest in HD 114283 isn't simply its fast cycle, it's its astounding age. Among the heavenly elements we've noticed, it remains one of the oldest, earning the enchanting moniker Methuselah star, compared to the scriptural figure Methuselah, who legend has it lived for a considerable length of time. Originally assessed to be a staggering 16 billion years old, the latest estimates suggest a rather younger time of 14.46 billion years, with a margin for error of 0.8 billion years. This discovery about its age baffles stargazers. After all, the age of the universe, contemplated from the vast microwave background, floats around 13.8 billion years. This issue raises significant questions about the star's age, the universe's age, and even the accuracy of our dating strategies. We must break it down. Figuring out the ages of grand objects can be a veritable enigma. Take stars, for instance. Like the sun, they're similar to immortal lights, maintaining their brilliance, temperature, and size for billions of years, making them fascinating to age date. Space specialists use changes in brilliance and color as hints, coordinating these with models predicting how stars change over time. One age giveaway is how fast a star spins, like a wheel slowing down over time. Stars do this, too. By looking at the rotational rates of stars at various ages, cosmologists have devised a clever trick called geochronology. Stars also spill their age secrets through magnetic flares and ejections of energy on their surfaces. Look at a star's vigorous fervor. Space experts, being the space detectives they are, use advanced techniques like astroseismology. It's like tuning in to a star's internal conversations, focusing on vibrations caused by waves traveling through its interior. These vibrations reveal the star's age. For instance, applying this astronomical sneaking around, specialists timed the sun at 4.58 billion years. Now back to Methuselah star. The old transmission around it isn't just inconsistent. Space specialists labeled it with an old age by checking its cosmic neighborhood. Stars can be categorized into groups based on how much bling or heavy elements like iron they have. Our sun is somewhat a metalhead, belonging to population I stars. Methuselah star, on the other hand, resembles an obsolete legend from population 2, possessing fewer heavy elements. It's the astronomical wink-out that helps cosmologists play galactic archaeologists, unraveling the age stories of these heavenly creatures. Now imagine a gathering of stars from the hypothetical population 3, which scientists believe might be the universe's most unusual gems. While they're still lurking in the background and haven't yet appeared in our telescope spotlight, cosmologists suspect these stars might be the legends of creation, containing essentially no heavy elements. To grasp the grand design, we ought to rewind to the universe's early days after the Big Bang. Picture an infinite kitchen filled primarily with hydrogen and helium, the universe's basic ingredients, around 92% hydrogen and 8% helium. Or, if we measure them overall, 75% hydrogen and 25% helium. In this astronomical symphony, the first performers on stage were the population 3 stars. They were immense and hot, consuming their fuel rapidly, changing hydrogen and helium into heavier components. When these early infinite monsters exploded, they spread these heavy components into the vast expanse, in line with the population 2 stars, forming a niche later, yet still known in humanity's early days. Their original materials were laden with heavy components, particularly iron. Many of them went through their divine life cycles, blasting into cosmic explosions and adding more heavy components to the overall mix. Finally, the population I stars, including our Sun, emerged as infinite mavericks, forming from cutting-edge gas mists mixing with remnants from the earlier population 2 stars. Now, the central inquiry. Does the cosmic story throw an endless curve at the theory of the ancient Big Bang? It's a head-scratcher, but here's the twist. There's a 70% chance that Methuselah's star, the old heavenly stray, could be in the vicinity. 13.66% agreeing with the age of the universe. There's likewise a 30% opportunity that this old heavenly vagabond's age is playing outside the grandiose rule book. Comparably, there's a 15% opportunity it's not very, as new yet significantly more youthful. Imagine rolling a standard 6-sided die and expecting that interesting 6. Mathematically conceivable, regardless of what these astronomical bends throw at us. What's sure is that Methuselah's star isn't simply a huge veteran. It's the granddaddy of stars. We've figured out how to give it an age label that is darn exact. Now here's where it gets awesome. Instead of scratching our heads about where Methuselah's star could be 2 or 3 billion years older than its astronomical neighbors, we should flip the galactic content. Imagine a scenario where the universe itself isn't quite so youthful as we once suspected it is. Prefer to grasp 13.8 billion years, attempting to get a handle on the tremendousness of space itself. If we turn the entire history of the universe into a grandiose schedule, with the Big Bang as the absolute most colossal New Year's fireworks, Earth wouldn't actually join the heavenly hammer until the last seconds of December 31st. Human written history is only a blip in time, covering only the last 10 seconds. Our inestimable specialists determine the universe's age by looking at old starlight, born 2 or 300 million years after the big explosion. As the universe extends, it gives this light a huge makeover known as redshift. Doing the math on both distance and expansion, specialists proclaimed an all-universal time of 13.8 billion years. However, hold tight, because the vast circumstance begins to get interesting. An endless mumble from the University of Ottawa suggests the universe might be a walloping 26.7 billion years old. Professor Rinder Gupta gets an intriguing speculation from 1929, made by Swiss stargazer Fritz Zwicky, and it's working up our vast understanding. This speculation confuses, suggesting that as light particles, photons, traverse the boundlessness of space over time, they lose a portion of their energy. Although this thought doesn't impeccably line up with what we've seen through our telescopes, Gupta proposes an astronomical trade-off. He suggests we can blend this theory with our current comprehension of a growing universe, making a sort of hybrid explanation for the redshift phenomenon. Now, secure your seatbelts. Changing the universe's age to a fantastic 26.7 billion years is no small feat. Gupta adds another win to the tremendous blend by combining the channel's light speculation with advancing coupling constants, a brainchild of hypothetical physicist Paul Dürr. This idea proposes that how particles interact might have changed over time. And hey, researchers have a history of tweaking the cosmic clock. During the 1920s, Edwin Hubble thought the universe was only a simple 2 billion years old. We've progressed significantly since then, refining our cosmic math. Increasing the universe's age is like taking a giant leap in our cosmic understanding. But we should pause for a moment. Whether this new perspective becomes the cosmic norm is still up in the stars. Whether humankind's written history is a basic blip of 10 or 5 seconds in the grand scheme of the universe, one thing's clear. The universe is a motherlode of old supernatural occurrences and unending motivation. Looking to our inestimable lawn, the Milky Way, there's a stunning cosmic tango having an effect on everything. Late estimates hint that stars on the edges of our galaxy are strutting their stuff in slow motion compared to their companions in different systems. What's the astronomical scoop? Well, There are a few theories, and one mumble is that our Milky Way might be running really short on an imperceptible colossal fixing called dark matter. This dangerous substance influences the gravitational dance of sublime objects. There's an inestimable riddle involving dark matter, the strange substance we can't see, but appears to play a gravitational back and forth in the universe. One chance shaking our grandiose comprehension is that perhaps we've been measuring dark matter wrong. Our general compass might point off course. Here's where the European Space Agency's Gaia satellite steps into the enormous spotlight. It's like our cosmic examiner giving complex insights into the dance of almost 2 billion stars, and our Milky Way considers it a vast development test. The satellite's exact estimations have driven space experts to re-examine their fabulous enormous notes. Stars at the external edges of our Milky Way appear to be going slowly, testing our old suppositions about their speeds. How do star speeds spill the vast beans about a world's wreck? It's like really taking a look at the size of a gathering by how quick individuals are moving. Equipped with Gaia's information, space specialists assessed the combined load of our world's gas, dust, stars, and that tricky dark matter to be around 200 billion times the mass of our sun. It seems like a cosmic heavyweight. However, here's the twist. It's on different occasions less than we recently figured. One hypothesis to settle this grandiose problem proposes we may have been a piece ungainly with our dark matter gauges. Perhaps there's less dark matter out there than we once suspected. In any case, hold tight. Estimating a system is like attempting the incomprehensible. It's broadly precarious. The information could have a few attributes, or our grandiose estimating tape could require a few changes. Still, other examination groups have joined the vast examination, and they all appear to be mumbling the same general tune. In the event that this fantastic revelation holds, it's like opening another section in our fabulous physics course book, a twist that might make us re-examine not just our own Milky Way, but every sparkly corner of the universe. As Stacy McCarr, a space master at Case Western Reserve College, puts it, this could be an enormous game-changer. Returning on an enormous excursion to the 1970s, when stargazer Vera Rubin and her immense group set out on a divine mission. Their objective was to concentrate on how stars moved in various worlds. The enormous playbook proposed that stars on the edges of a universe ought to be inestimable doodlers, contrasted with the zippy stars closer to the middle, like how Neptune takes its time, surrounding the Sun, while Mercury is the boundless speedster. Here's where the unforeseen improvements come in. Rubin and her stargazing team revealed a galactic shock. Stars at the far scopes of worlds were strutting their stuff at almost the same speed as the ones nearer to the infinite dance floor. Imagine an enormous disco where everybody, paying little mind, is moving to the same beat. This enormous disclosure implied the presence of something confusing and secret, dark matter, the imperceptible heavyweight champion that forms gigantic coronas around universes. Think about early space specialists like Copernicus and Kepler. We've gained some useful knowledge from that point forward. Yet we're still the learners, looking wide-peered toward at galactic wonders, attempting to tackle the universe's secrets. Our Earth is like a little island in the tremendous expanse of space, spinning around the Sun, encompassed by endless stars. In our little universe, our journey for meaning among the stars is the core of logical investigation, even at the point when answers shock us. This interest keeps us voyaging further into the universe. It's an unending excursion where every reaction brings new inquiries, guaranteeing our grand examination never stops. The universe keeps on astounding us with its gigantic thickness and intricacy. Each disclosure leads us deeper into the complex embroidered artwork of galactic history, revealing the key regulations that govern our reality. Late investigations have shown that cosmic systems are confined elements, as well as interconnected through an intricate snare of dark matter and gravitational powers. This understanding leads us to re-evaluate our models of world development and evolution. One of the most intriguing parts of vast examination is the idea of gravitational waves, swells in space-time brought about by some of the most outrageous occasions known to humanity, like blending black holes or neutron stars. Previously identified in 2015, these waves offer a better approach for noticing the universe, providing bits of knowledge that customary telescopes could miss. They open a window into peculiarities that are imperceptible to electromagnetic radiation, permitting stargazers to sort out occasions from the early universe and improving how we might be able to interpret the crucial powers at play. Also, researchers are likewise investigating exoplanets, planets circling stars outside our solar system. The disclosure of potentially tenable worlds raises significant questions about the chance of life beyond Earth. Strategies like travel photometry and radial speed estimations help identify these far-off planets, revealing different planetary frameworks that challenge our suppositions of how solar systems ought to form. A portion of these exoplanets remains in their star's livable zone, where conditions may be ideal for liquid water, a vital component for life as far as we might be concerned. As we test further into the universe, the job of artificial intelligence in examining huge sums of information turns out to be progressively significant. AI calculations can recognize designs and oddities in heavenly light bends, prompting the disclosure of new divine bodies and peculiarities at a speed beforehand inconceivable. This association between human instinct and AI pushes us into a period of amazing inestimable standing.